Okay, so let's look at page 16. We're going to solve this problem. Log x squared equals to 2. Before we solve these kind of questions, because these are log questions, log has a defined domain. If it's exponential, the domain is all real numbers, but with log, it's not. So we have to look at the domain. If you don't know what the domain is, you can look at 2 pages ago. So yesterday we did go over the domain of log x squared. So you can look at the pages 2 pages ago. What is the what's the domain of log x squared? Huh?
Everything but 0.
Everything but 0. So x can be 0. Or negative infinity to 0 and 0 to infinity. Okay, so whatever answer you get, it just cannot be 0. All right, so let's think about how we're going to solve this. Log x squared equals to 2. In order to solve this problem, we got to get rid of the log, right? Because we're trying to solve for x. That means get rid of things that's farthest from x. And that means log. How do we get rid of this log? Raise the base by 10. Yes. So whatever that log base is, we raise by the same base to get rid of the log. So this log has a base 10. So we raise by base 10 on both sides. All right. X squared equals 10 squared. What does x equal to? Oh, so close. Yes. Plus minus 10. Every time you square root, you have plus minus. Every time you square root, you have plus minus. So the answer is plus minus 10. None of them is equal to 0, so you're good. Let me show you the wrong way to solve this. And you probably wouldn't even know that was wrong because you are actually still following the rules. So let me show you the wrong way to solve this. Log x squared equals to 2. So you might have looked at it and said, you know what, I can do this. Log rule says I can bring this exponent down. So you could have done this instead. If you did that, what would be the logical thing to do next? Yes, divide by 2. So log x is equal to 1. And then what would you do next? Raise by 10, correct? So then x is equal to 10. And then you lose one of the answers. Why is that? Yes, you got rid of the square. So at the beginning of the problem, you can see that it tells you there are 2 answers or 2 potential answers. You changed it, so now you decrease the degree by 1, makes it easier for you to solve, but then you lost one of the answers. So please don't change the question. I guess that's the thing. Don't change the question. If you change it, you might lose the answer. Okay, so please be careful. All right, this problem. This is where we're going to have some issues. Okay, so we have 3 logs added together in some way, right? So you're going to think of it as in chapter 1. Chapter 1, we said if we have a function added to another function, we call that combining functions, right? When we combine functions, we always said to find the domain, we find the picky eater. Do you guys remember that? So we have 3 functions added together. We have to figure out what the domain is for each one, and then we have to find the pickiest eater, the pickiest domain. All right, so in this first function, natural log 3x minus 2. All right, so let's kind of think about it. Natural log domain has to be greater than what? Huh? Yes, greater than 0, always. So this part always has to be greater than 0. 3x minus 2 always has to be greater than 0. Whatever goes inside the log always has to be greater than 0, or else it's undefined. So then x is greater than what? What do you guys think? X is greater than what? 2/3. Okay, so that's the first function. The second function, same thing. This part has to be greater than 0. So x minus 1 has to be greater than 0. So then what does x have to be greater than? This last one. So this is where you do not change the question. Don't move it to an x squared. If you do, you are saying that negative numbers are okay, right? Because you're saying I'm squaring everything, so I can put negative numbers in. But it's not true. That's not the original problem. The original problem is just 2 natural log x. So this part has to be greater than 0. Okay, we have 3 functions. They're all added together. So they're combining together, which means they're all going out to eat after school. Who is the pickiest eater? X is greater than 1. Okay, you need to be able to see this. So we have 3 numbers. 0, 1, 2/3. Greater than 0, greater than 2/3, greater than 1. Greater than 1 has the smallest amount of numbers. So x greater than 1 is the domain. Whatever answer you get, it has to be bigger than 1. All right, you're going to solve this out graphically first. That means you're going to graph it and figure out when when y is going to be 0. What x value will make this equal to 0? Okay, let me know when you have the answer. Huh? Yes, 2. Okay, so now you're going to solve this algebraically, and you should get 2. Okay, natural log 3x minus 2 plus natural log x minus 1 minus 2 natural log x equal to 0. I'm going to tell you 2 things that most students, if they're going to make mistakes, this is what they do. First, you're trying to solve for x, so you see there's a bunch of natural logs. So the first thing that most people think about is, I got to get rid of the natural log. How would you get rid of the natural log? E, right? E has the same base. So this is the first mistake people make. They do this all across. This is not okay. You cannot distribute an e because e is a function. It's not a number that you can distribute. So this does not work. If you do this, it's a guaranteed wrong answer. So first mistake, please don't do that. What can you do instead? Yes, you actually do have to combine. You have to combine them all into one log before you can start. So first thing is you have to combine into one big log. Yeah, they're all the same kind of log, so you can combine them. Yes? Okay, so you're going to combine them. Now, how are you going to combine them into one log? Times the first 2 and then? Divide. However, this is where the second mistake comes in. There is a 2 in front, right? We cannot divide as is. We have to get rid of all of the coefficients. So this has to become an x squared. Now, remember I said in the beginning that you can't change it to an x squared? It's okay when you're just solving. You're not changing the domain. Does that make sense? No. Okay, so in our domain, we said this has to be greater than 2/3, this has to be greater than 1, this has to be greater than 0. That's okay. If I change it at the beginning and then I said, hey, look at this domain is just x not equal to 0, then that domain is incorrect. Then I might get a number that I think would work, but actually doesn't work. Does that make sense?
So we switched it if we fell on x squared, but we would make it like all real except 0.
Yeah.
Which is like we start off with.
Yes, then that would be incorrect. But if you're just changing it to solve a problem, that's okay because you're still gonna go back and check your domain anyways, so it will still be fine. All right. Okay. Well, yes. Let's solve it. Okay. So that becomes an x squared. So natural log 3x minus 2 plus natural log x minus 1 minus natural log x squared equals to 0. All right. So we have a plus and a minus. That means we're going to combine together. 3x minus 2 times x minus 1 divided by x squared equals 0. What should we do next? Before FOIL. We gotta get rid of the natural log. How do we do that? Yes, raised by e. That's gone. E to the 0 is what? 1. Yes, 1. Please don't put 0. Okay, now this is just a very simple problem of a rational function, which you did last chapter. How do we solve this? Times what? X squared, you mean?
X squared.
Yes, x squared. All right, go ahead and solve from here. Remember, whatever answer you get has to be greater than 1. All right, once you solve, you should get 2 answers. X equals 2 and 1/2. 1/2 doesn't work because it's not greater than 1. 2 is the only one. Okay? All right, you're going to practice this next one. Let me know when you're done. Okay, the answer is 3.11. Okay, this is the only answer that works. All right, we're really quickly going to go into applications of log. So first, we're going to talk about order of magnitude. Order of magnitude is a way of classifying things by how many magnitude or orders of 10. Is this one bigger than the other or smaller than the other one? So let's look at the first example. How many orders of magnitude is a kilometer bigger than a meter? 1 kilometer versus 1 meter. Okay, the first thing you're going to do is you're going to change them so that they have the same unit. So 1 kilometer is how many meters? 1,000, yes. So 1,000 meter versus 1 meter. The next thing you're going to do is you're going to change both of them into a kind of like a scientific notation. So some magnitude of 10. So 1,000 is what in scientific notation? Scientific notation?
10
Do you guys remember scientific notation?
Yes. Yes, I remember.
Okay, it's always a number times 10 to the something.
Would it be,
1 times 10.
would it be 10 times -2 or 10 times?
Okay, the first number has to be a digit,
Yeah,
not a
10 to the third.
1 times 10 to the third. 1 times 10 to the third. What about,
You need to learn number.
okay, what about 1?
Oh, 1 is 1 times 10 to the 0.
0. Okay, so when you're asking for orders of magnitude means how much bigger is this exponent to that exponent on the orders of 10. It has to be a 10 to something degree. Okay, so it's going to be 3 versus 0, so that is going to be 3 orders of magnitude bigger. 3 orders, orders of magnitude. 3 orders of magnitude bigger. You have to look at the question because this question is asking for orders of magnitude. How many orders of magnitude is it bigger? It's 3 orders of magnitude. If it says how many times bigger, it's 1,000 times bigger. Okay? 3 orders of magnitude bigger is 1,000 times bigger. 3 orders of magnitude means it's 10 to the third bigger. So 3 in the degrees of 10, but it's actually 10 to the third times, that's 1,000. 1,000 times bigger. All right, so let's go ahead and have you do the following. 1, 2, 3. How many orders of magnitude bigger is each one? $1 and a penny, a horse weighing 400 kilograms and a mouse weighing 40 grams, a population of 8 million people versus a population of 8 people. Okay, try it. If you don't know how to do it, let me know. 1 penny is 1 cent. 1 cent, 0.01. Number 1, 2 orders of magnitude. Number 2 is 4 orders of magnitude. Make sure you subtract the exponent. Number 3 is 6 orders of magnitude. All right, now let's take a look at a real-life scenario with earthquakes. So there is a earthquake in 2001 that is Richter scale 7.9. There's another earthquake in 1999 that is 5.9. We're trying to figure out how many times more severe. So that means we're going to compare the amplitude. Richter scale is according to this formula. So what we want to do is kind of figure out how many times worse is A more than, for the first one more than the second one. So let's say R1, which is 7.9, that is log A over T plus B. So we're going to say that T and B are both constants. It doesn't really matter. It's the same for every earthquake. So the only thing that's changing is A. So then this is going to be A1 since that's the only one that's changing. R2 is 5.9, which is log A2 over T plus B. We're trying to figure out how much worse is A1 over A2 because they're asking for how many times worse, not orders of magnitude. So we are going to actually subtract R1 and R2. Okay, so that's going to be 7.9 minus 5.9, which is the same as saying log A1 over T plus B minus the whole R2. So that's log A2 over T plus B. All right, 7.9 minus 5.9 is just 2. Log A1 over T plus B minus log A2 over T minus B, because I just distributed the negative sign. You can see that B is going to cancel, right? We're left with log A1 over T minus log A2 over T equals 2. What can we do to combine those two logs? Because they're both base 10. Any thoughts? Yeah?
A1 over A2.
Yes. So we can actually divide the two logs, right? So we can say it's log A1 over T over, what's it, T? Over A2 over T. And hopefully by this time you can do the reciprocal in your head. So divide by A2 over T means you flip it up and then it's going to be multiplied by T over A2. So in your mind you can see that T is going to cancel. So this is just going to be log A1 over A2 equals 2. Okay, what's the last thing we need to do if we want to figure out how much A1 is bigger than A2? Yes, raised by 10. So A1 over A2 is 10 squared, which is 100. So it's 100 times worse. It's 100 times worse. How many orders of magnitude worse? 2. Okay, 2 orders of magnitude worse, which means 100 times worse. Okay, so when you see somewhere on the news it says this earthquake was, 8, compared to that other earthquake that was 7, it's not only a little bit worse, it's 10 times worse. Does that make sense? Okay, last example. Chemistry example. Make Miss Cosaway proud. Okay, so we have a vinegar that has a pH of 2.4 and a box of baking soda that has a pH of 8.4. We are going to determine the following. What is the hydrogen ion concentration? Okay, all right, so I need to give you this formula. pH is equal to negative log of hydrogen ion concentration. So the way you measure pH is how much hydrogen ion is in that thing. So vinegar has a pH level of 2.4. That means 2.4 is equal to negative log of hydrogen ion concentration. So if we want to figure out what the concentration is, what do we have to do first? What do you have to do first to solve for H+? We had to divide by negative. Okay, what's next? Raised by 10. Now use your calculator. 10 to the negative 2.4. Can you change it to scientific notation?
Yeah.
Oh, sorry.
It's gonna be 3.89.
Okay, and this is in moles per liter. Okay, now you're gonna do the same thing for baking soda. Baking soda is 8.4 pH. Okay, so do that, and then what you're gonna do is B and C. How many times greater is the hydrogen ion concentration, and then how many orders of magnitude is the difference in the concentration? So in baking soda, it's 3.98 times 10 to the negative 9. So the amount of times it's worse or bigger is 10 to the 6. That means 6 orders of magnitude.